Hello, this is the Tepid Coder. In this video, I want to talk about something that makes me a very tepid coder. That is code distribution and code signing. It used to be, back in like the Windows 98 days, you didn't have to worry about this sort of thing. You can make your application, customer can download it, they can run it, then they're happy. Of course, it was always unsafe to download an exe from the internet and just run it. It's nice to have this idea of trust, but in order to get the trust that you need with code signing, you need to have a code signing certificate and have it be, vetted by some trusted source. And in order to get that vetting by a trusted source, you have to pay money. So that's kind of a problem. It basically means you have these middlemen that are allowing you to sell things without customers thinking that you're trying to give them some kind of a virus. And I don't like that. I consider it to be a form of extortion. And I think that some of these companies that are flagging things as viruses without knowing for sure, instead of just saying, we can't confirm this is good, we're actually saying we detect that this is a virus, it's a Trojan, it's whatever. I think that should actually be illegal because it is actually costing people business. And I think that you can have pretty easy metrics as far as how many downloads you get from your executable file and how many actual runs of your executable you get if it connects out to a server or something and like confirms that it's been run, right? You can kind of tell based on that it is damaging your business because maybe people are downloading it but not actually using it and they're deciding not to pay for it after their trial or something because they didn't even end up running it after they downloaded it. Anyway, I want to see a class action lawsuit on that at some point, but I'm not going to be the one to frontman that. Not right now, anyway. Anyway, let's say I make this application here. It's a really wonderful application that prints hello world, and your customer needs that for some reason. So we're going to build it. Test CP. The output's going to be test. Cool. Look, I can do that. Hello world. So you want to send this to your client. Well, if you host it on your server and they download it, it's very likely it's going to say that, hey, first of all, this isn't signed. That's a problem. We can't trust this. That's the first prompt they're going to get. And they can see it run anyway. The second problem they might get is a false positive for it being a virus. Now, I've noticed sometimes if I sign things, the warning about it being a virus magically goes away. And I've done things too where, just as a sanity test, I'll compile something on one computer, I'll transfer to the other computer by multiple methods, one through the browser and one just through like SCP or like a thumb drive or whatever. And if I do it through a thumb drive or SCP it back and forth, typically I won't get the whole thing where it says it's a virus, but I have had that happen. But I usually get the thing where it says like it's unsigned or whatever. Fine. But I've also had it say it's a virus, especially when I download from a browser. It sounds like it comes from the web, right? So it just trusts it less. And it just assumes it's a virus and gives it some like Trojan name or brainworm or whatever it's going to be called. Okay, so I do that. I run over there. It says it's a problem. And I'll run like the Windows Defender on it, like on this end. If I go Explorer, I run it in this directory. I can actually right-click on this. I can say scan with Microsoft Defender. And if I go over here, you'll say, one's file scanned, 0 threats found. Great, because I compiled it on this computer. But if I run it on the other computer and I scan it, it's going to say maybe it has a virus. Not always, but sometimes. It can be the most basic of applications just like this. Like I've had this exact example. I compiled it with MingGW. I compiled it with like Visual Studio, and I might have compiled it with Ceiling. And either 2 out of 3 or 1 out of 2, whatever, would say it's a virus, right? And of course, if I scan it locally, it's not going to say that. And then if I build the same exact application on the other computer, and I scan it, it says no problem. And then if I transfer that back over to the first computer, it's going to say, again, it's a virus, right? Because it's not signed and came from the web, whatever. So anyway, I just kind of wanted to get that out there to explain that this is an actual problem, and you should sign your code. But you also shouldn't pay people money. I think if you pay these middlemen, it's going to empower them. Don't help people who are making your life harder and ruining your business. You shouldn't reward their bad behavior. So I'm going to show how to make your own code signing certificate without paying anybody. So here's what you do. You say open SSL. By the way, I'm doing this all through Git Bash here. One of the things I need to do to convert it into a .p12 file that I'm going to use with the sign tool on Windows is not going to work with the Windows terminal in a way that I've seen. You need something called winpty. Anyway, here we go. So we're going to do gen RSA. We're going to do 2048 greater than some file. I'm going to call it cert.key. This is the key for my certificate. Okay. So then I'm going to do open SSL req. I'm going to do -new -x509. That's what you use for a code signing certificate. The type is an x509 certificate. Okay, -nodes, and we're going to do SHA-256 for the hash. We're doing days 365. So it's going to last for 365 days. This is good if you have something like a company full of employees and you have one person who handles things like your CI/CD pipeline and unit testing and whatever, yada yada. Maybe they also are the person who like issues code signing certificates. You might have people like leave the company and they could be using your certificate for things that they shouldn't be. You can make it expire pretty soon, right? So you might want to use it this day's thing here for that reason. I'm just going to make it 365 days. I'm no one using the certificate, so I'm not worried about someone using my certificate to sign some malicious software, thereby making my certificate no longer trusted. Like, it would damage the company. So anyway, it's going to last 365 days. I'm going to say key. I'm going to say cert.key, I called it. And then the output file is going to be cert.crt, let's say. Okay, so the country I'm in is the US. State, PA, Pennsylvania. We're going to do a county name. I'm going to say Pittsburgh. I don't live in Pittsburgh, but I live close to there. Company name. I'm going to say DBA. Doing business as myself. DBA again. Okay. Your name. The tepid coder. Okay. Email address. Don't docs at mebro.net. Okay. So now I have a code signing certificate, but I can't actually use this with the Microsoft Sign tool. I need to convert it from a .crt file into a P12 file. So I'm going to do winpty, and we're going to do openSSL pkcs12 export out. I'm going to call it cert.p12 when I make it. Now I need the key file. So in key is going to be cert.key, and I need the actual certificate that I made that I'm converting. So in is going to be cert.crt. Okay, export password. I'm just going to say test. Test again. Cool. So now I should actually be able to sign with the certificate. So you can see I have in this directory an executable file to sign. I have the P12 certificate I can use to sign, and the password I made was just test for this. So now you have to use the sign tool. You can either do that through going to be Program File 66 as Windows kits, then to be 10 in my case, and it's going to be, I think, binary. I'm just going to pick the newest version, x64, and then it's called sign tool. You can either reference that explicitly just from this path, or you can just go to I'm gonna say developer. Here it is, developer command prompt for VS 2022 right now is what I'm using. Okay, so I'm gonna go I'm gonna go to code coder and code signing. Okay, now I can actually use that sign tool. If I do sign tool -h, it knows that path to that sign tool, so I don't have to do the whole explicit path to the sign tool. That's kind of nice. So sign tool, I'm going to say sign to -fd. I'm going to specify the type of hash I want. It's going to be an SHA-256 hash. I'm going to do /t for time. I'm getting my timestamp from a third-party website. It's http:// going to be timestamp.komodoka.com/f. We're going to do, okay, cert.p12. That's the file I'm going to sign with. That's my actual key file, or certificate file, I mean. And the password /p, test was my password for this, test.exe. Okay, so I do that, boom, added the additional story to it. So I can do explorer dot, okay, so I'm in the same directory now. If I actually right click on this, I can go to properties, I can go to digital signatures, and you can see right here, tepid coder. So right here, don't dox me, don't dox it, mebro.net. And yeah, you can see it actually signed it. So when I get it onto another computer, what they can do typically is actually install the certificate if they want. And then as I release new software and sign up with the same certificate, they won't be getting these annoying prompts that are kind of scary to the end user and make them think that maybe it's going to be something dangerous they're running. And yeah, anyway, this does help in my experience. I've had things go from saying it's a virus on both ends. Computer 1 builds it and moves it to computer 2. Computer 2 runs it, says it's a virus. While scanning on computer 1, not a virus. I do the same thing in reverse. Computer 2 builds it, put it back in computer 1. Computer 2 says it's not a virus, but computer 1 says it is. As soon as I sign it like this, even just with this custom code signing thing, it's not validated anywhere. It has no root certificate. It's like verifying me. Just that one step is enough to where it's saying, okay, fine, maybe it's not a virus, but we don't trust it. And you still get the first prompt, but you can run anyway. So this does help, basically. So for anybody out there who is trying to distribute applications and they're having it, turbo rejected by Windows, I hope this will help you. And if anyone else in the comments has other things they've done to help with this issue, where Windows thinks it's something that shouldn't be trusted, and or thinks it's a virus until so many people have run it and used it and trusted it and whatever, I'd like to hear your thoughts and your procedures. But I'm not about to pay $60 for an individual code certificate, which still needs to be what do I say, trained. It needs to be trusted as more people use it. Or like an organizational code signing certificate, which again will help with the initial prompt, but it's still, you start with zero trust. And I'm definitely not paying the $400 to $600 for the extended validation code signing certificate, which lets me just skip the prompt and the smart screen and all that. That's just a shakedown fee. It's extortion, in my opinion. So I'm not supporting that kind of business practice. And if it really comes down to it, if I have to distribute something, I might even just have it run through some like a VM or something, because the VM itself would be trusted. It would have its own certificate. So if you have people run something through like a Docker image or something, probably that wouldn't have an issue. Although you're going to limit your clientele then to people who are comfortable installing and configuring Docker images to run the software. Anyway, if anybody here found it useful, give it a thumbs up, consider subscribing for more content like this, and yeah, leave any comments, suggestions, criticisms. I'd like to read those, because there might be easier ways to do the same thing I did, there might be better ways, and so forth. Anyway, I'll catch you guys in the next one. Happy coding.